Good evening, guys. Audible at last? Okay. So we'll start with the session. Okay, so what we were discussing in the last class? So we were discussing about the ER diagrams, right? So in the ER diagrams only, a lot of terminologies we have discussed. So we have discussed about like what is an entity, attributes, different categories of attributes, relationship, cardinality ratio, which is nothing but what? Are types of relationship. So many things we have seen. So to draw any of the ER diagrams, so this is very much important. Okay, and before I start talking related to the technical, so let me tell you guys that on Saturday we had one off campus placement, which was happened in the TAP Academy only. So Saturday the drive was conducted. Okay, maybe you guys are still a new batch, so you have joined it recently. I don't know how many of you guys have applied it, not applied, I don't know. But let me tell you guys that whatever they have the expectation from the students, and even the question paper also that I have seen that from the SQL it was very simple questions. It was just creating a table and it was just an inserting a values. Nothing was there apart from that. So probably still we have not seen here that how to create one table and how to insert a values inside that. We have not discussed. But I am telling you guys that you never know that a companies, when that companies will be coming. So whenever they are coming, see this kind of things are a very good opportunities for the students that to get placed. But many of them due to the lack of revision, even that simple questions that they will not be able to answer. And they will be losing the opportunities. The clients was clearly, they were communicating with us that see, they are freshers. We just want them to speak out. We just want them to explain what they know. But still there are students who are in the position that they don't do the revisions, they neglect the things and they miss the opportunities. So please start doing the revisions from the day one. Any important discussions is going on there? Don't listen even this instruction, don't listen everything, so leave. But when the time comes, that is when you will start realizing how important things are. So much of simple questions, in future if they are asking you, make sure that at least you guys start doing the practice and at least get answer, not even the difficult questions. It is very simple questions. So that is why I am telling each and every terminology that what we are discussing, and none of the questions were asked out of the box. A coding questions, a theoretical questions, SQL questions, everything which we have taught in the class. So whatever you are learning on the daily basis, make sure that you do the revisions on that. Otherwise, you will keep on missing the opportunity. So please don't miss any kind of an opportunity because every opportunity is important. So please start doing the revisions. So we'll move to our technical things here. Okay, so in the last class we have seen that. So we had a scenario, we have seen that how that particular scenario has to be converted into an ER diagram. Means before we start constructing our table, it is important to have a proper plan. Why? Because every time we cannot develop, we cannot again remove the tables, all that will be a very tedious task. So that is why it is important to do what? It is important to plan. After planning, then only you have to start following the rules which we have seen. That is creating a table, specifying the column names and data types and insertion of the values. So here, whenever you have converted the scenario into an ER diagram, this is not the only thing that is sufficient. Now, to create a table to specify the columns and data types, don't you think that you should be aware that what the name should be there for a table? And what are the column names should be present? So all that you should be aware. So if you are not aware all that, you cannot construct a tables. You cannot specify the columns. See, whenever you are creating a table randomly, if you specify the columns, does it make any sense? No. So whatever you are doing here, it should be meaningful and it should be related to what data that you are handling with. So it is important to know what should be the table name, what should be the column names. And based on that columns, what kind of a data that you will be storing, based on that you have to also choose the data type. And then only you have to start doing what? You have to start inserting the values. So, in the ER diagram that whatever we have seen, anywhere was it clearly said to you that no, this should be the table name, this should be the column name. Have we discussed that? No. Why? Because in the ER diagram, only the representation and planning will be there. But after that, there is something, other thing also which you have to know before you start developing, before you start constructing your tables. That is, whatever the ER diagram it is there, now that ER diagram only you have to start converting into the relational schema. ER diagram you have to convert it to what? You have to convert into the relational schema. Now, what is this relational schema if you ask me? See, relation we already know. Means here whatever the data that we will be dealing with, every data will be interrelated with each other. And every data will be having a sort of relationship between each other. So, that only will be telling as what? Relation or relational. So, now what is this schema is what that you have to understand. Basically, schema is nothing but it is one database. So, schema means what it is? Database, where in the schema a collection of tables will be present. Basically, a schema is nothing but what it is? A collection of tables. Now, when we have a collection of tables, don't you think that we will also be having a large collection of facts and figures? When we have a multiple tables, inside that multiple tables, definitely we will be having a data. So, when multiple tables are present, so definitely if we are combining everything, it will become a large collection of facts and figures. So, that is why we have to call that as what? As a database. So, sometimes people will be calling this as a database, sometimes people will be calling as a schema. In our database also we will be having what? We will be having a collection of tables. We have seen an university database in the last class. Right, in that many things we had. We had about a student entity, we had a course entity, we had a faculty entity, we had a semester and so many things that we had in one database. So basically that is nothing but it is also called as what? Schema, where schema is nothing but there we will be having a collection of tables. Now whatever the ER diagram we have, that ER diagram, what we have to do? We have to convert that into what? Into a relational schema. Means properly now we have to convert them into a different tables. So there in that different tables again, just the tables will not be there. Every table should be interrelated with each other. That is why it is not called only as a schema. It will be called as what? Relational schema. Because whatever tables we will be having, that tables will be having a sort of relationship. Why? Because in ER diagram also we have seen between every entities they have given a relationship. They have given what? They have given a types of relationship as well. So that is what that we have to convert. So before converting, two important points that you have to understand. What is the two important points that you have to understand here is, whatever the entities that we were calling for so many days, entities, whatever we were calling as an entities, that entities only you have to make as a table names. So whatever we have taken an entities, that entities will become what? A table names. So in our university table, it means how many tables we should have? 5 tables. We had a department table, we had a semester table, we have a course table, we had a faculty table, and we had a student table. So entities, that whatever we have to take them and we have to give as what? We have to give as a table names. So in the student, we will be having the student related data. In department, we will be having the department related data. So like that, from each of that thing, we will be having that related data. So entities should become as what? As a table names. Now, for that entities, we had an attributes. What we had? We had an attributes. That attributes only we have to make as a column names. So what we have to make an attribute as a column names. So understand, in the interviews, sometimes they can tell you, I want you to create one table, and in that I want you to have 5 attributes. 5 attributes in the sense what? 5 columns. Suppose if they tell, I want you to create a table, in that I want you to have 5 columns, in the sense what? We should have 5 attributes. So attributes only are also called as what? Columns. So whatever entities we had, we have to take them as what? As a table names. Whatever the attributes we had, that we have to take as what? As a column names. Now based on that, we can assign a data type as well. Now if I have an ID, I know sometimes it will be an integer. If I take a student name, I know it will be a sequence of characters. So based on that, now we can assign a data type as well. So in this only, that if you know till here, you can satisfy the 2 rules. One is creating a table, and inside that we can specify the columns, and for that we can give what? We can give the data types for that particular column as well. So here we have to see what? Converting that particular ER diagram to what? ER diagram to the relational schema. So schema basically it is a collection of what? Collection of tables. And it is also be called as what? As a database. Why relational? Because between every table we will be having a certain kind of the relationship. So now that 2 important things you have understood. That entity should be the table names, attribute should be what? Should be the column names. So here let us take that one example that what we have. So this is as an individual we have seen. We have seen this, right? Faculty is one entity. So for that faculty, how many attributes we had here? 3 attributes. So what are those? Faculty ID, name and email. In that one attribute we made as what? As a key attribute. And that key attribute is very important, that in every entity we should have at least one key attribute. Why? Because that will allow us to efficiently fetch our data. So we are thinking about the future also. We are not only storing here, but after storing definitely we have to fetch it also. So we will not be doing the task individually. We have to do them together. We have to think all the possible things. So that is why that key attribute also it is present. So now same thing only what we have to do. Now we have to convert into a relational schema. So that entity should become what? Should become a table name. That attribute should become what? Should become as a column names. So this is how that our table, basically we know table means what? We will be having rows and columns. That is what we will be having. And that individual thing what we will tell as a cell. If you have worked on the Excel sheet, probably that structure you would have been understood. So we will be having a columns, we will be having a rows, that individual smallest units that what we will be having, that we will be calling as what? As a cell. Same concept applies here also. So table will be containing rows and columns, and that smallest part of our table we will be telling as what? As a cells. So here you can see that first I have taken what? I have taken a faculty. What is faculty here? It is an entity. So that has to become as what? As a table name. And now inside that what we should have? Columns. So what should we have? Columns. So whatever attributes are there, that only here it will become a columns. So in this table, how many columns we will be having? 3 columns we will be having. So we will be taking all that particular 3 columns that what we have. And here one more important thing is, here in our ER diagram we have something called as an unique attribute. Basically a key attribute also we have. So that also we have to represent here. Why? Because that is an attribute which we can identify uniquely, where that values for that attribute should be unique. Repetitions should not be there. Because your IDs are repeated? No. So everyone has what? As an unique ID. And everyone will be having an ID. If ID is not there also, we have to tell as what? That they don't belong to the TAP Academy. If the repetition it is there also, it is not valid. So in our ER diagram, whatever that a key attribute, as a key attribute we will be telling there. So same thing only, as soon as you convert into a relational schema, basically as a table. So same thing only, you have to start calling it as a primary key column. So what you have to call it as? Primary key column. Again that primary key column also we will be having a same representation, because it is nothing but it is an unique attribute only. Representation will be what? Representation will be an underline. But in the ER diagram we have to tell that as what? As a key attribute. But as soon as you convert into a relational schema here or into a table, you have to call this as what? As a primary key column, where this primary key column should not contain a duplicate values, and it should not contain an empty values also. In other words, a null values should not be present. So primary key column, what and all should not be present? Repetition of value should not be there, or null values, that is an empty value, should not be there. If either one, if it is there also, we need to understand that that is not a valid data. And whatever data that we are entering, it should be valid and it should be proper and correct. Otherwise, it doesn't make any sense of creating a table and inserting a wrong data inside that. So, it is important that a primary key column will be containing a unique values, and it will not be containing the null values, or empty values will not be present. So, this is how that I am just taking some random data here. Okay. See, this data you have to focus whenever we are creating a relationship. Right now we have dumped the data. Right now we have given a data, and see in that faculty ID any data is empty there, or any data it is repeated there? No. So here there is only one task for us. Take an entity, make it as table name. Take an attribute, make it as column names. Take a key attribute and make it as primary key column. So till here it is fine. So similarly, same way only that whatever we have drawn that particular ER diagram in our last class, basically an university ER diagram, this everything as an individual table, that this is how that we have to create. So what and all we have? We have a department. In that department we add a key attribute, department code, that we made as what? We made as a primary key. Same thing applies for the faculty also, course also, semester also, and student also. So entity we have taken, and what we have done? We made it as a table name. Attributes we have taken and we have made it as what? As a column names. Key attribute we have took and we have made it as what? As a primary key column. So till here it is fine. So every entity we took and we have converted into the tables. But here only the things doesn't end. Here only the things doesn't end. Because we have a relationship also, right, which is very much important again. Why? Because here it is not about just creating a table, it is about creating a table and creating a relationship between them. Because this is our DBMS, this is not only DBMS. So till here it is fine, but we have created a relationship between our tables as well when we have drawn an ER diagram. So now how do we create that relationship practically? How do we show that relationship in terms of this relational schemas or in terms of this table is what that we have to see. So let us see that how that representation that which we will be doing here. So same here individually that I will be taking. So first I am taking this. So one is faculty and one is course. And we have what? We have the takes. Means here what we had in our last scenario, one faculty should take only one course. That was a type of relationship that which we had. One faculty should take only one course. So now this is one table and this is one table. Yes, faculty is one table and course is one table. Now we have to take that both the tables that what we have here, but after taking both the tables we have to create this relationship as well. So how do we create that relationship practically when it comes to the tables is by using a key which is nothing but a foreign key. Like how we have a primary key column here, like that we have a one more key which is nothing but a foreign key, where by taking that foreign key, by using that foreign key, we will be creating that relationship. And first of all, what is this foreign key? If you are asking me, now I have this table, I have this table. Right now if you see, I don't know which faculty is taking which course. And I don't know which faculty is handling which course here. That information only is not present. Why? Because we have not related them, right? If we have related them, that information I will get. But if we are not relating them, will we get that information? No. That is also is one reason that where you have to create a relationship between the tables. If you are not interconnecting them, then you cannot have the proper information. So as I said, by using that foreign key, what we can do, we can create that relationship. Now, what is that foreign key if you ask me? That foreign key should be the primary key or unique column of the other table. For example, here, I wanted to know that which faculty is taking which course. I wanted to know which faculty is taking which course. So here 101, which faculty is handling it. By telling here the faculty ID, will I come to know? Suppose if I tell here the faculty ID, then I can clearly tell which course is handled by which faculty. I can tell or no. So here if I am including the faculty IDs which I already have in that other table, then I can clearly tell that which course is taken by which faculty. So here suppose if I am bringing the information like this. So I will bring up what? I will bring up the faculty ID here. As I said, I am bringing here what? A faculty ID, and here I will be giving what? I will be giving the certain values here. Again, when we are bringing up that foreign key, what that foreign key should be present as? Primary key of the other table or an unique column of other table. So, whenever I am bringing here, this will be called as what? As a foreign key column. And this foreign key column is represented by the dotted lines. Foreign key is represented by what? Dotted lines. And what is this foreign key? This foreign key in this table is a primary key or a unique column of the other table. See, usually I give this general example to everyone because that is how that you will be correlating it. Say, suppose if someone comes from outside the country, for us what they are? They are the foreigners. Because they doesn't belong here, they are coming from some other place. Suppose if we go to any other country, for them, we will become what? We will become a foreigners. Why? Because we doesn't belong to that place, but we are going from the different place. So, same concept applies here. So, here, this column, whatever it is there, it is not directly belongs to this table. Have you seen that column there? No. So, here, I wanted to create a relationship. So, what I am doing? From there, I am bringing here. From the different table, I am bringing that column here. So, since I am bringing it here, in this table, this will become as what? As a foreign key column. And this is represented by what? As a dotted lines. So, by using this foreign key, what I can do? I can create a relationship between the tables. And that foreign key should be the primary key column or an unique column of the other table. So, till here, relationship is done. But what about the cardinality ratio? That is also as important. By using a foreign key, what did I do? I have created a relationship. But I should also showcase the type of relationship where one faculty takes only one course. So that 1:1 type of relationship also I have to showcase here. How we can showcase here is by giving up the values here. So here I will be giving up the values here. Tell me, any faculty ID is repeating here? I have only this many courses, so total 6 courses I have. And I have said that 101 course is taken by 91 faculty ID. So this is a person that who is handling what? Who is handling the 101 course. And the 91, who is that? It is Rohit. So this is how that now can we tell which course is handled by which person? Yes. But if you see here very carefully that none of the faculty IDs are repeated here. It means that one faculty is handling only one course. So you need to understand here 2 things. One is by using this foreign key, I have created a relationship. But type of relationship how I am showing? By inserting this particular values. By seeing that values only, I can tell whether it is 1:1 or whether it is 1:many, many:1 or many:many. So that depends on what value that we are giving here. So this is how we will be having a tables. This is how that relationship that we will be creating, and this is how that we will be showing that cardinality ratio or type of relationship. So basically these 2 points are very much important. Primary key and foreign key. What is basically a primary key? Basically it is one key attribute where it will be containing only the unique values and it will not be having an null values or empty values will not be present. And what is foreign key? By using that foreign key, we can create a relationship between what? Between the tables. And a foreign key of one table should be the primary key or unique column of the other table. And how we will be representing the foreign key? By the dotted lines. And how do we represent the type of relationship? By inserting the proper values. So this is how everything that we have to start converting into the relational schema. Now you have the tables in front of you. Now you know what is a table name. You know what are the columns should be present. Now by seeing that, by analyzing the data, you can give what? You can give the data type as well. And you can insert the values as well. So if you convert that into the relational schema only, you will be getting a complete clarity about what you have to construct and how you have to construct. So similarly, let us see the other types also, because every type of relationship here it is important. Every type of relationship here it is important. So here what I have here, I have a department and I have the faculty here. So both the tables that we will be taking. We will be taking a department also and we will be taking up the faculty also. Now, do we have any relationship between both of them right now? Right now, do we have any relationship? No. So, right now, both are individual tables. Right now, both are individual tables. If we take that foreign key only, it means that we have created a relationship. Now, I have a department, I have a faculty. So, in one department, we can have multiple faculties. We can have, right? That is what the relationship that which we have given. 1 is to many. That in one department, we can have multiple faculties. But which faculty belongs to which department? Still, I am not aware. That I can only get when I create a relationship. So what I'll be doing here, I wanted to know which faculty belongs to which department. So I'll be taking a primary key from this and I'll be giving as a foreign key to the other table. So here I will be creating that here. So here I will take as a department code, and this department code will become what? As a foreign key. So now I have created a relationship. So now we have to see with respect to what? A type of cardinality ratio as well. That whether in one department do we have multiple faculties or not. So that how we can find? We can find it by giving what? By giving the values. Now tell me, in 201 department, how many employees are working? 2 employees are working. So it means in one department we can have multiple faculties. We have created a relationship also. Now we have gave that type of relationship as well. So now I can easily tell which faculty belongs to which department. And in one department, how many faculties are working. So this is how that we have to convert them into the relationship. This is how that we can create what? We can create a relationship. So next, similarly, here also we have one more scenario, that is a course and semester. So again, here also when we are taking the course and semester, right now they both are 2 individual tables. We don't have any relationship between them. We have to start creating a relationship. So here what I have here, semester I have, course I have. So in one semester can I have multiple courses? In one semester can I have multiple courses? Yes. So here also that we have given that 1 is to many relationship only. Okay, so in one semester we can have multiple courses. So which course belongs to which semester? How will I come to know? By taking this primary key and I have to make as what? As a foreign key. So I will be taking that. So there I will tell the same thing as a semester code, and once I take that will become as what? As a foreign key. And whatever the values are there, that values we will be taking. So see, 001 semester, how many courses we have? 2 courses we have. So in one semester we can have multiple courses. In one semester, we can have multiple courses. And this is what is the relationship also that which we have given when we drawed an ER diagram. Again, it's the same thing only. Same concept here. So, foreign key is there. That foreign key should be the primary key or the unique column of the other table. So, as soon as I bring up the foreign key there, it means that I have created a relationship, and by seeing that values, we have to tell as what as a type of relationship that what we have. Whether it is 1:1, 1:many or many:many, all that we can easily tell. So, let us see the next scenario here. So, what I have here? So, semester and student. So, here can I tell here as multiple students will be present in one semester? Multiple students can be present in one semester. So, here I can take as what I take? I can take as many:1. Many:1. So, in one semester I can have multiple students, and multiple students can be present in one semester. So, same thing that we will be taking as what? We will be taking here as a tables. So, what I have here? Semester. So, here we will be taking as usual primary key we will be having. So, semester value, whatever we have, start date, end date, all that we will be having, and similarly we will be having what? A student table as well. So, here also we will be having what? We will be having a primary key. Here also primary key is present, there also primary key is present. Means in every entity we should have at least one key attribute. Similarly, in every table we should have at least one primary key. Why? To fetch our data properly. So, this is how the values that we will be having here. Now, which student belongs to which semester? I don't have an idea. Why? Because we have not created any relationship here. So, we can create that relationship there. So, by taking this semester code. So, here I can make that as a foreign key there, and whatever the values we have, that values we can give. That values that we can give. You can see that multiple students are present in one semester. Tell me in 001 how many students are there? 2 students. So, it means multiple students can be present in one semester. So, here what kind of relationship that we can tell? Many:1. Multiple students can be present in one semester. And if you see here, we have seen 1:1. We have seen 1:many. Now, we have seen many:1 type of relationship as well. Now, for all these scenarios, if you are seeing it very carefully, I have created a relationship by using our foreign key only. By using a foreign key only, what we have done? We have created a relationship. And based on the values, what we have done? We have tried to explain about the cardinality ratio as well. But you need to more focus on this scenario, which is very much important, that is many:many relationship. This is where that a little bit more concentration, a little bit more importance that you have to give whenever you are creating a table. So, here also I have 2 individual tables, one is a student and one is course. So, same thing that I will be taking here, one is a student and one is course. One is a student and one is course. Now, right now both of them are 2 individual tables. One student can obtain multiple courses. Am I right? In one course I can have multiple students. So, that is why they gave here what type of relationship? Many:many. That one student can be present in, can obtain or enroll to the multiple courses. In one course we can have multiple students. So, in both the direction whenever we are seeing, we will be getting 1:many, 1:many. So, when we have that, we can directly make, if at all if we wanted, as what? As a many:many relationship. So, now I'm just giving you an example. I'll take that primary key there, I'll bring here and I'll make here as a foreign key. Now, I have one course code there, that is 101. In one course, multiple students can enroll. Multiple students can be present. Yes. In 101, assume 2 students enrolled. Because it's a valid only. In one course, we can have multiple students. Now, in 101, assume 301 and 302, both of them as enrolled. Can I come here and tell 301, 302? Logically, it is not correct. In one cell, we have to give a single value only. We should not give more than one value in our tables. This is a rule. If at all if you try to give also, it will not accept, it will start throwing you an error. So here, in one course, I can have multiple students. If I am making here a foreign key by taking that student ID, if 2 students are there, I cannot tell here 301, 302, that is not valid. So here, I cannot bring a foreign key. Now let us see in this direction. I'll bring a course code here. Now 301 student obtained 2 courses. 301 student obtained 2 courses. I'll tell 101 and 102. Both the courses are obtained by 301 student. So suppose here if I bring course code for 301 student, can I tell 101, 102 also? No. Why? Because in our table, each cell should contain a single value only. We cannot have more than that. So, in both the cases, since that I have that many is to many relationship, where it is not possible to create a relationship by using a foreign key. Understand? Whenever we have a many is to many relationship, we cannot create a relationship in our table by using what? By using a foreign key. If I am doing that, then in one cell, more than one value I have to give. But that is not possible. But we have to create a relationship. So that is why we have an alternate approach. We have one more key which comes into the picture whenever we have a many is to many relationship. So basically what is that key is? It is nothing but it is a composite primary key. What it is? It is a composite primary key. When you have to go with the composite primary key is whenever you wanted to give a many is to many type of relationship. Why? Because in that case, by using a foreign key, I cannot create a relationship. So now, what is this composite primary key mean? Why? Because by this time you understood what is a primary key and what is a foreign key. But now what is this composite primary key in the sense? Now, from this table, we will be picking up our primary key. From this table, we will be picking up our primary key. From this table, taking a primary key. From this table, taking up a primary key and making it as a separate table. What it is? Making it as a separate table. So here, what I will be doing, as I said, see student ID, course code. What is a student ID? It is a primary key in this table. What is course code? It is a primary key of this table. And if you see course title, that as an additional column I have given. That is nowhere related to your relationship. Just understand one additional column is present there. Okay, here we have course title. But here I am telling that why we have taken here is as an additional we have taken. But this is nowhere related to your relationship. Just additional I am taking. Okay, now what did I do? From this table I took a primary key. From this table I took a primary key. So when I took both the primary keys, and now in this table, this will become as a composite primary key. And that composite primary key, in the sense, more than one key attribute together we will be making as one key. We will be making as what? We will be making as one key. So this will be called as what? As a composite primary key. Now you can see, whatever underline I have given, I have not given a space here. I have not given a space here. This is together, now it is one key. So more than one key attribute if you are taking, if together if you are making as one key, that will be called as a composite primary key. And how exactly this composite primary key will be working and how this primary key will be working, I will tell. See, how this primary key will be working. First I will give 301. After that I will give 302. What it will do? It will compare our values as what? Whether it is unique or not. Whether that value is proper value or not. It will compare. So this value will be compared with all the values like this individually. But here that is not the case. Here whatever the values that we have here, I am taking, see, student ID I am taking a course code here and I am giving that title as well. How here it will be working is 301 101 together, now it is a key. Together now it is what? Key. Tell me 301 101 anywhere again repeated. See it as a together. Why? Because now it is not individual. You might think, ma'am, 301 301, but this is primary key. Right now this is not a primary key. Now what it is? It is a composite primary key. And again, this is not an individual key. Along with this you have one more also. So that is why together it will be taking up a value and it will be comparing. So 301 101 nowhere repeated again. And 302 101 nowhere repeated again. So this entire value it will be taking and it will be compared with the other values. So this is how the composite primary key will be present. So now you can see 301 student has been enrolled to 101 course also, and that student has been enrolled to 102 course also. Both the information I have here. First student, 301 student can obtain multiple courses. See, he has obtained 101 also. He has obtained 102 also. Similarly, 101, you can see one course can be obtained by multiple students. In one course, we can have multiple students and one student can obtain multiple courses. So, every information I have here. And you can see each cell contains a single value only. Each cell contains what? A single value only. So this is how that whenever we have a many is to many type of relationship, we cannot create a relationship by using a foreign key. So we have to go with what? We have to go with the composite primary key. So what is composite primary key? Bringing up the keys, that is a key attributes or key columns as more than one and making them together as what? As a single key. So that is called as what? As a composite primary key. And when we have to go with the composite primary key, when we have many is to many relationship. And what is the representation for that? Underline, same. It is an underline only. But you should not give a gap there. Completely you have to represent as what? As one one underline, and you have to represent that as what? As a one key together. So that is how the operation will be performed. And one more important thing that I wanted to tell you guys here. Primary key column can accept duplicate values? No. Primary key column can accept the null values? No. Foreign key column can accept duplicate values? Yes. Why? Because whenever we are creating, suppose if I am taking a department and I am creating, in one department multiple students can be present. Yes, so understand, in our foreign key we can have a duplicate values, and sometimes in our foreign key we can have an empty values also. What if the faculty is joined newly? Directly will they assign any department? Directly will they assign to any department? No. In that case, that will be an empty only, right? Once they got trained, once they understood their skills, then only they will be segregating the departments. So a foreign key column can contain a duplicate values also. A foreign key can contain a null values also. Null, basically it is an empty data. Empty. Understand what it is? It is an empty data. In the composite primary key, can we have a duplicate values? Can we have a duplicate values? No. Again I am telling, don't see values like this. Together you have to start seeing. Anywhere did I give a duplicate value here? No. Even in the composite primary key, you cannot insert what? You cannot insert a duplicate values. And even null values also you should not give. So this differences that you have to understand. What is primary key? What is foreign key? What is composite primary key? What is the difference between them that which we have? And this is how our complete ER diagram we can convert into what? We can convert into the relational schemas. So this is how that you have to convert. Right now, you know what is a table name. Right now, you know what are the columns that you have to give, and you know how to create a relationship as well. And you know that yes, data we have to insert once we have created a table, once we have specified the columns, and for that once we have specified the data types, automatically we can insert what? We can insert up the values. So, let us see that practical thing that how I can create one table. And inside that, how can I specify a column? And for that column, how should I give the data type? So let us see that one small part practically. And I am hoping that already in the LMS MySQL installation video, it is already there. Please kindly go back, check. If you have not installed, please do install it as soon as possible and start working on it. And here, when it comes to the MySQL, two things are there. I think this already I have said. One is command prompt, MySQL command prompt. One is MySQL workbench, which is nothing but a graphical user interface. In our classes, we will not be using a graphical user interface. That I will be teaching you at last, as how you have to use that graphical user interface. But in our classes, when you are practicing, make sure that you practice in the command prompt. If you already have a knowledge about the MySQL workbench, you can start working. I don't have any problem with that. But in the command prompt also, you have to know how you have to work, because that is where you will learn many things. Because there it will not show what is an error. You will start rectifying the errors. You will start correcting it. So make sure as what? Make sure that you have that MySQL. Once you install both the things you will get. Command prompt also you will get, workbench also you will be getting. And install 8.0. Suppose if that is not supporting, go with 5.7. Okay, either one, everything, working everything, it will be same only. So you no need to worry about that. So here I will just show you the command prompt. So here you can see that this is a command prompt. Now you no need of doing anything, you no need of setting any path, nothing is required. After downloading, after installing, again I am telling, whenever you are installing, it will ask you one password. Make sure you give the password as root only. And don't forget your passwords. Why? Because that password is very much important when you start learning JDBC in your Java. That day don't come and tell that ma'am I forgot my password. Now it is not getting connected. That password is very much important to have a connection. So give a password as what? As a root only. Please don't give any kind of other names. Give as what? Give as a root. Make it standard. So now how you can open this tool is, you have a search in your system where you will be searching your applications what you have installed. There just go and type as MySQL command line. See again, in the system there will be two commands, command prompts. One is normal command prompt. I am not talking about the normal command prompt. You should not open that. You should open MySQL command line. So just type as MySQL command line. You will get it. Once you open, this is how that screen that you will be getting. And you can see on the top, first it will be asking you to enter a password. What it will be asking you? To enter a password. So password as a root, that whatever you have, give that particular password there. Then directly you will be connected to your MySQL. You no need of setting any kind of path. You no need of setting any kind of path. So directly you can give a password, you can get connected to what? Get connected to the MySQL. And here, one thing that you have to know, first here I have to start creating a tables. Yes? So what I have to do? I have to start creating a table. Here in our MySQL, before you start creating a table, you need to create a database as well. What you have to create? You have to create a database as well. Inside that database, how many ever tables that you wanted to create, you can create. How many tables you wanted to keep it in that database, you can keep it. But before creating a table, what you have to do? You have to create a database. And multiple databases you can create. It's not that you have to create only one database. We can create multiple databases. But to create a table, what it is required? Before creating table, what we should have? Database. So first we have to do what? We have to create a database. Now, before I create a database, I just wanted to see what are the other databases that are already available in my system. Why? Because the name that which you will be giving for your database, it should be unique. The names that you will be giving for your tables, that should be unique. That should be unique. So that is why what I will do now, I will just see what are the list of the databases that are currently available in my system. So here, whatever operations that we wanted to do it in our MySQL, we have to do it by using the commands. I want to create a table, I have to use a command. I wanted to insert a values, I have to use a command. I want to create a database, I have to use a command. I want to remove a database, I want to remove a table, I have to use the commands. So whatever operation that which we will be doing in our MySQL, we have to do it by using what? By using a commands. So here, to see that list of the databases, I have a command. So what is that command is? It is nothing but it is the show command. So what is command it is? It is a show command. Now what I wanted to show that list of the databases. It is not database. What it is? It is a databases. So I will tell show the databases that are available in my system currently. Show is what? It is one command. Databases here, it is a keyword. Show what it is? It is a command. Databases is what? It is a keyword. So here, now, in the command prompt, whenever you wanted to execute any statements, you have to give a semicolon. If you are not giving a semicolon, your statement will not be terminated and your statement will not get executed as well. So, I'll give here a semicolon and I'll click on enter. Can you see how many list of databases I have already here? So, these are the databases that are already present inside my system. So, whenever I am creating a database, I need to make sure the name of that database should not be repeated. If it is repeated, it will not be executed. Understood? So first, how to check the list of the databases? By using a show command. So now I got to know what name I have to give. Now I have to create what? I have to create a database. So for that also I have to use a command. So what is that command is? Create. Because I want to create a database, right? So what is the command we have? Create. What I have to create? What I have to create? It's a database. So I have to tell, I want to create one database. And then I have to give the name for my database. So here I'll just tell as July B1 batch I am giving. So I am just giving one database name as what? As July B1. So what is the command which I am using here? Create. And I am telling I want to create one database and give a name for the database as what? As a July B1. And if I want to execute this statement, what should I give here? Semicolon, and after that I have to click on enter. Can you see what I am getting here? Query OK. So this is how that we have to do what? We have to create a database. So now when we are listing the databases, can you see July B1? Can you see July B1? So this is how that what we have to do. We have to create a database here. Okay. So this is how that we have to create a database, and we can see the list of databases. Okay. So please do practice all this. The continuity part of creating a table, everything we'll see in the next class. Okay, so thank you everyone. We'll meet up in next class. Thank you all.
Recording stop.